become 0. Okay, right? So then so basically when you have a when you have a 0 at omega equal to 0, this would correspond to a constant rise of 20 dB per decade for our magnitude. Okay, but where does it start from, right? Because you remember that we don't actually have an origin on the Bode plot. The origin depends on the problem that we are solving. We never can do the origin at omega equal to 0 because log of 0 is not defined, right? This is in dB, right? So do we know log of 0? No, it's not defined, right? But we know that log of 1 is, what is log of 1? I'm making a mistake here. This should be 1. And this is 10 to the power 4, let's say. This is 1, 10 to the power 0 or 1. What is log of 1? It is 0, right? So we know that our 0 line, it's gonna cross here. This is the impact of the 0. Okay, so we have two components now. We have a pole and we have a 0. So we basically just have to add them up, right? So you see that the pole doesn't have any impact up to 10 to the power 4. So everything, it's gonna be, let me just like do the actual Bode plot now. So everything, it's gonna be like our 0 behavior up to this point. And after this point, our 0 wants to increase the magnitude by the rate of 20 dB per decade, and our pole wants to reducing the magnitude by the rate of 20 dB per decade. So these two would cancel out each other. So this is the magnitude plot of our problem. So I can just like remove everything else. So this is, I'm sorry about that. So this is what our magnitude is gonna look like. So the case that we have 0 or pole at omega equal to 0, it's a special case. When you have a pole or 0 at omega equal to 0 or at j omega equal to 0, the impact of the impact on the phase, it's just gonna be constant, right? So what is the magnitude of negative j omega? Sorry, what is the phase of negative j omega? It's gonna be negative 90, right? So this is gonna be the impact of our 0 on the phase. What is the impact of our pole on the phase? You remember that now we have a pole at omega equal to 1, should be actually 10,000, right? This should be 10,000. Again, I made a mistake here. Because this is 10 to the power 4. Okay, so we have a pole here, right? So the impact of the pole, it's gonna start 1 decade before, and it's gonna last up to 1 decade after. So this is gonna be the impact of our pole, and the red line is the impact of our 0. Right? And to draw the Bode plot, we just have to add these two together. Right? So up to this point, if I again draw this in black, up to frequency 1000, j omega equal to 1000, the pole's impact is nothing, right? So we're gonna have 90-degree phase up to this point, and then the pole causes the phase to drop down with the rate of, what's the rate? Negative 45 degrees per decade, right? So this is gonna come down here, and it basically settles down at negative 180 degrees. So I can now just get rid of the pole and zero here, and this is basically the Bode plot. This is the magnitude, and this is the phase Bode plot of this problem. Now, so this is how you can draw the magnitude and phase Bode plots. Now I wanna ask you to do what I asked you to do in question 3. So let's say our input is 10 sine 2 pi 60t plus 30 degrees, which is pi over 6 radian. And I want you to tell me what is our output in time domain. Okay, how do I find this out? So this is a linear problem. Okay, so it means that when we have a sinusoidal input, we're gonna have a sinusoidal output with the same frequency. The frequency is not gonna change. The magnitude and phase are gonna change, but the frequency, it's gonna be the same. So I can write down my output like this: sine of 2 pi times 60t plus something, which I don't know what it is. And I don't know what the coefficient here is, what the magnitude is. This is pi over 6. Okay, so now how do I find the magnitude and how do I find the phase of the output? The magnitude of the output, it's gonna be, oops, sorry. Okay, the magnitude of the output, it's gonna be magnitude of input multiplied by magnitude of hj omega at the frequency of input. Okay, so what is this one? We already calculated it, right? We don't look at the dB in this case, we just look at the actual value. So if I just replace omega with 2 pi times 60, I would have the magnitude here. So it's gonna be 2 pi times 60 times R2 times C1 divided by 1 plus, I'm just gonna write down 120 squared times pi squared.